Hello guys, and today we are going to look at hello guys, welcome again to my channel. Today we are going to look at thermochemistry. It's the third episode of the series, episode 3. We're going to focus on thermochemistry. So let's dive right into it. So thermochemistry is a branch of chemistry that deals with heat absorbed in a chemical reaction. Okay, so the reaction can also be exothermic, one that releases energy, or endothermic, one that absorbs energy. This change in energy can be represented by delta H, change in enthalpy, right? So as per now, what we've learned is delta H is the change in enthalpy, right? Delta H, that's how it's represented. So enthalpy is the change in energy. So delta H is equals to change in enthalpy in the reaction. Okay, so we're going to use this chemical equation to try and learn more about thermochemistry. So CH4 plus 2OH2 is equal to CO2 plus 2H2O, right? You've gotten that. So let me just elaborate on the equation. C, let's say it's carbon, right? It has 4 H's, like the C is in the middle, and then there's a H, right? C, H4, right? Plus OH2 with a 2 in front of it. This can be elaborated. The the element looks like 0 is equals to 0 and another 0 is equals to 0. So 0H2 with another 2 on it, right? You get it? So CH4 plus OH2 2, right, is equals to 2CO2, right? CO2, which in that part, maybe I shouldn't be looking into the equation that deeply. Well, it's 0 is equals to C is equals to O, and then H2O, 2 of them, right? 2 in front of H2O. So it's 0, it's O, and then 2 H's, and then O, and then 2H, right? That's H2O2, right? So energy stored in the result minus energy used in the reaction. Like in this equal signs we've looked at, in the result, it's the energy used as a result of the reaction. Like in the equals, the result, the energy minus the energy used for the reaction. Okay, so if more energy in product, delta H will be positive, the reaction is endothermic. Less is exothermic reaction. You followed? Okay, let's just go fast. I think you can keep up as per now. Energy is the capacity to do work and can have many forms. For example, here's some of the example of the energies. We have mechanical energy, electrical energy, and chemical energy, which is battery. So mechanical energy is like mechanical energy, electrical energy is lightning, chemical energy is battery. So energy can change form like heat. Energy can change form like heat. Energy in a broken bond released cannot be destroyed. Actually, I just realized I'm working with someone similar, so I'll just be straight to it. You catch it the same way I caught it. He didn't need to repeat anything. I just caught it. So heat always flows spontaneously from one area of high to low temperature. When Q is positive, the energy was absorbed, but when Q was negative, the energy was released. So temperature and pressure, when constant, Q is equals to delta H changes in entropy. We discuss energy in terms of joules, J, kJ, which are kilojoules, and calories, which 1 calorie is equals to 4.184 joules. So 1 calorie is the amount needed to raise temperature of 1 gram of water by 1 degree Celsius, right? So these are not the calories in food, they're different calories. Oh, that time of the show. Drip check. That's what I'm marking. Style on 100. Let's go back to the class, right? Enough about that. So where were we? These are not the calories in the food. It's different calories used to measure I won't say temperature, but like energy in chemistry. Okay, so a thermochemical equation reports the change in enthalpy reaction in a metric terms. We'll go into another chemical equation. CH4 plus 2O2 is equals to CO2 plus 2H2O, right? So the delta H is equals to 890.3 kilojoules over mole. Number of moles in a reaction can change of enthalpy would be as listed. The number of moles reacts the change of enthalpy would be as listed, right? As listed in the equation. If twice as much would be twice as much as listed. So if there was twice as much energy, there would be twice as much in the delta H listed, right? So so if 10 grams of methane combusts, how much energy is released? Delta H is equals to 890.3 kJ. That was methane being reacted, right? And you've been given like the kilojoule chemistry. Brilliant, huh? So internal energy in a system is equals to Q plus W. Delta E is equals to Q plus W. So Q represents the amount of energy that enters or leaves a system, right? So just please write it. So let me give you an example so you can learn about this stuff. So let's say we have a system in a box. That's the system, right? And it's 100 degrees Celsius in the system, right? In the system, right? And then you release heat to the surrounding, which is 25 degrees Celsius. So the system is releasing heat, so Q is equals to negative, so the reaction is exothermic. But when the surrounding is receiving heat and is getting hotter, the temperature is increasing, Q is equals to positive, which is endothermic, right? Thermochemistry, it's brilliant. Q is measured in joules, right? W represents work. You're with me? I believe in you. W is equals to P delta V, which W positive on the system and W negative by the system. Really? I mean, if you say this. Never mind it, the moment's past anyway. So 101.3 joules is equals to 1 liter times LATM. 300 joules absorbed by the system is equals to 2 liters into 3 liters is equals to negative 5. That means 3 minus 2 in brackets is equals to negative 5 LATM. That's the equation we've been calculating. So negative 5 LATM over 1 times 101.3 joules over 1 liter times LATM, which times I mean on a dot, like, is equals to negative 506.5 joules. You're telling me you didn't get thermochemistry when I taught you? You got it, right? It's not been a breeze like the other episodes. Well, if you didn't get thermochemistry properly when I taught you, you might have to refer and get all the gist of thermochemistry. It's pretty brilliant. I choose not to go into it that much, but I took this opportunity to give you a class in it. You'll get it, don't worry, but the class is more important. I enjoy the chemistry being offered. So Q can be calculated by Q is equals to MC delta T. That's how you calculate Q. So CH20 is equals to 4.8184 joules over G degrees Celsius. So 54 grams of ice transferring into water is equals to delta H first is equals to 6 kilojoules over mole 1, right? That's the example when ice is being melted into water, and the types of joules and the delta H, which will be used. Pretty sure you got it. So that's it for thermochemistry. I believe it was a bit brief, but we dabbled into some chemistry today. I taught you a thing or two. I hope you learned so much. I hope you learned the class. I know I did. That's it for today. Until I see you again. Austin.